Number 2 says use synthetic division or the factor theorem to determine which roots work. I would suggest using the factor theorem so that way you don't have to test out a bunch of things with synthetic division because that can take up a lot of space, but it does work. I'm going to test out one. I'm going to test out x equals 1. So we'll do 1 to the third plus 10 times 1 squared plus 17 times 1 minus 28. So cleaning that up a little bit, we end up with 1 plus 10 plus 17 minus 28. And when we combine all that, we end up with 0. So x equals 1 does work. So we got x equals 1, which as a factor, we would write as x minus 1. Now to find some other ones, we can keep testing out a whole bunch of them, or we can use synthetic division. Once we know one of the roots, we can just factor that out to find the other ones. So I'm going to factor that out. So I'm going to put 1 in the box, and then we're going to use the coefficients of 1, 10, 17, and negative 28 to see if we can factor this down to something smaller. So I'm going to drop that 1 down, multiply that by 1, add those together. 10 plus 1 is 11. Multiply that by 1, and we still get 11. 17 plus 11 is 28. 28 times 1 is still 28. Add those two together, we get a remainder of 0, which is great. So when we put that when we use those coefficients for our reduced fraction, or sorry, not reduced fraction, reduced function, sorry, we get x squared plus 11x plus 28. So that's what we get when we factor out that x minus 1. And that we can factor out even further. So even further, we got to look at x plus blank, two numbers that multiply to 28 and add to 11. That'd be 4 and 7. So our other roots are x equals negative 4 and x equals negative 7.